Hi friends, welcome back. Today we're talking about finding the area of a rhombus or rhombi, multiple, and kites when you have a missing length. So just a quick reminder, this is your kite and this is a rhombus. A rhombus, remember, has all the same sides on the outside. But for both of them, the formula is the same. You take the diagonal 1 or diagonal 2, multiply those two together, and then divide by 2. So let's launch right into this and see what we've got here. All right, so we're going to find the area of this rhombus first. So the first thing I want to do is, remember, area equals D1 times D2 divided by 2. Okay, so with that said, we're going to need this whole one and this whole one. Now, in a rhombus, these are bisected. So two things. We know this is a rhombus because we're told it's a rhombus. Also, we see that these are all the same. And we know that these guys bisect each other. So if this is 24, this is also 24. But now we have to do a little problem solving. And that's what math is, folks. Math is not learning math. It's learning how to solve problems. We have to do a little problem solving here to figure out what this guy is. Because once I figure out what this is, I'll know what this is. And then I'll have my long diagonal and my short one. So let me redraw this. It looks like, let me poorly redraw this apparently. There we go. And we know this is 26 and this is 24. I need to figure out what that other guy is, X right here. So I see that I have a right triangle. I don't know the angles, so I can't use my special right triangles, but what I can do is X squared plus 24 squared equals 26 squared. Okay, so X squared equals 26 squared minus 24 squared. I just minused 24 squared from both sides. Now, if you do this way, it is not 2 squared. You can't do 26 minus 24. It doesn't work that way. But you can enter it into your calculator as 26 squared minus 24 squared, which gives us 100. So X squared equals 100. Square root both sides. We get X equals 10. Okay, so this guy right here we now know is 10, which means this is 10, which means this is 10. So now we're ready to find our area. So let's do our area in a different color so you can see it. The area equals diagonal 1, and it doesn't matter, diagonal 1 can be this way or this way. So we'll say 10 plus 10 is 20, times 24 plus 24 is 48. And then whatever that is, we divide by 2. Now I could multiply 20 times 48 and divide by 2, but you can also just cross cancel. Divide by 2, we get 1. Divide by 2, we get 10. The area equals 10 times 48 gives us 480. Oh, and it's meters. I forgot to point that out at the beginning. Meters squared. So the area of this rhombus is 480 meters squared. All right, let's take a look at this next one. Oh, we got another rhombus here. So I act surprised like I didn't assign these problems. Okay, so we've got another rhombus here. What we're gonna do is we are only given one side, so we know that's 4, so that's kind of helpful because what we can say is, oh yeah, this is 4 as well. So now I have a triangle here that looks somewhat like this. I am the worst at drawing, so bear with me. 60 degrees, and this is 4. And we remember 30, 60, 90, that is a special right triangle. So here's my 30 degrees. Opposite 30 is my M. My hypotenuse is double that. This is M root 3. Okay, so we now know that since this is 4M, this side over here is going to be, we just plug in our 4 for M and we get 8. So we use this color. So this is going to equal 8. And because we know M equals 4, over here we know this is going to be 4 root 3. Bam. Okay, so this is 4. This is 8 over here. And this is 4 root 3. This is 4 root 3. So I don't really care about the 8 on the outside. That's not really helpful because the formula is, again, it's too many markers. I get excited about the markers. Okay, so the formula again is area equals D1 times D2 divided by 2. So our area is our diagonal 1, 4 plus 4 is 8, times, now 4 root 3 plus 4 root 3. 4 root 3 plus 4 root 3. Remember, think of it like 4x plus 4x, you would get 8x. You get the same idea here, 8 root 3. So this long diagonal is 8 root 3. All of that is divided by 2. So to simplify this, we get 8 times 8 is 64, root 3 divided by 2. Divide this by 2, I get 1. Divide this by 2, I get 32. That was supposed to go through both those. There we go. And so my answer is 32 root 3, and we're talking meters, so meters squared. So my area is 32 root 3 meters squared. All right, now let's take a look at the kite. So for our kite here, we have, all right, let's start with this guy. Find the area of this kite. Okay, so we look at this, and again, we want to do this diagonal and this diagonal. Now, on a rhombus, the diagonals are bisected, but on a kite, they are not. They are bisected right here on this one where the angles match. These angles do not match. So when they're bisected, remember, bisect means cut exactly in half. So if we take a look at this triangle here, we have a right triangle, and I want to find this, so I'm going to call it X, right? So we've got 18x and 30, and we know it is a right triangle because this is a kite, and with a kite, all the diagonals make right angles. So we now have 18 squared plus x squared equals 30 squared. We got our Pythagorean theorem here. So if we minus 18 squared from both sides, we get x squared equals 30 squared minus 18 squared. Throw that into our calculator. We get 30 squared minus 18 squared. We get 718. Oh, that is not right. 30 squared minus 18 squared gives us 576. 576. All right, let's square root both sides. And so if we square root 576, we end up with 24. X equals 24. Okay, cool. So now that we know that this guy right here is 24, this is also going to be 24 just because the nature of a kite, those guys are bisected. So to find the area, we'll use a different color here. So we've got, I'm getting markers all over me. The area is going to equal this diagonal. Oh, it helps if I put you on the screen. 18 and 42. So that is 40. So 50, 60 times 24 plus 24 is 48 divided by 2. Okay, so if we do that, divide this by 2, we get 1. Divide this by 2, we get 30. So we end up with 48 times 30 gives us 1,440 centimeters squared. Centimeters squared for that area. So remember to use, so part of your toolbox is the Pythagorean theorem and our special right triangles or our reference triangles. All right, let's look at this kite. So for, a little high, there we go. So this one's going to be a little trickier. So we're going to do some challenges here. First things I see is this is a 45-degree angle, which means this is also a 45-degree angle up here. Remember, with an isosceles triangle, and this is isosceles because those angles are both the same, that means these sides are also the same. So this guy is M because this is M and this is M. And remember, in a kite, this diagonal bisects itself. So this is also M. The area of the kite shown is 135 kilometers squared. So find the length of M. Okay, so in this case, what we have is M plus M. So that's 2M times M plus 6. All of that divided by 2 equals our area, which we know is 135. So in this case, let's move that 2 over to the other side. We're currently dividing, and the opposite of divide is multiply. So multiply both sides by 2. Good, and if we do that, we get 135 times 2 will give me 270. Okay, so 2M times M plus 6 equals 270. Whoop, there we go. Okay, so then we've got do 2m squared, so we're going to distribute, plus 12m equals 270. Okay, so now I look at this and I see that all of these can be divided by 2, and that'll make my life a little bit easier, especially because I'm dealing with a quadratic. So m squared plus 6m equals 135. Let's go ahead and set that equal to 0. Whenever you see a quadratic there, it's always a good idea just to set it equal to 0, because that usually will help get you back on track. So minus 135 from both sides, I get 0. All right, so let's see if we can factor this guy. So this tells me different signs, so plus, minus, and so I have 135. You want to list out all your factors, but I think if we do 9 times 15, that should work, because I need a positive 6. So if I do negative 9 plus positive 15, that would give me a positive 6. So negative 9, positive 15. All right, let's use our zero product property to do m plus 15 equals 0. Minus 15 from both sides, I get m equals negative 15. M minus 9 equals 0. Add 9 to both sides, I get m equals 9. So I have m equals negative 15, m equals 9. Now, let's think about that in terms of geometry. We can't have a side that's negative 15. So this goes away. And what we have is that m equals 9. So we now know this is 6, this is 9, this is 9, and this is 9. So hopefully this helps. If you have any questions, leave them below or ask your teacher, and we'll see you next time.